Writing code that actually works, that's one thing. But writing code that can stand up to a real attack, well, that's a whole different ballgame. It takes more than just technical chops. It really requires a specific way of thinking. So today, we're going to dive into that mindset using one of the most influential development books ever written as our guide, Microsoft's classic, Writing Secure Code. So, before you can even think about writing secure code, you have to understand the battlefield. And what's so powerful about this is how it just lays bare the huge fundamental imbalance in cybersecurity. The book calls it the attacker's advantage and the defender's dilemma. Think about it. An attacker, they only need to find one little flaw, just one. But the defender, they have to protect everything. The attacker can get creative, try brand new things nobody's ever seen before, while the defender is usually stuck protecting against attacks we already know about. It is a tough, asymmetrical fight from the very beginning. Okay, so what happens when that defensive mindset is completely missing? Well, you get vulnerabilities. And for decades, the undisputed king of all vulnerabilities, public enemy number one, has been the buffer overrun. It is the perfect, and I mean perfect, case study of a simple coding mistake that leads to absolutely catastrophic consequences. Now, the name buffer overrun sounds super technical, right? But the concept behind it is actually surprisingly simple. Imagine you've got a moving box, that's your buffer, and you're supposed to put, say, 10 books in it, but instead you try to cram 20 books inside. What happens? The box breaks, of course, and all those extra books spill out into the next box over, crushing that fragile vase that was sitting right there. A buffer overrun is basically the digital version of that. You pour way too much data into a memory space, and it just spills over, corrupting or completely overwriting whatever happened to be next to it. And this is where we get to the real-world cost of these mistakes. And it is staggering. According to the book, back in the early 2000s, it cost Microsoft an estimated $100,000 just to issue a single security patch for one bug. One! And look, that figure doesn't even begin to touch the millions more in damages for all the customers who got compromised. It just shows how one sloppy mistake can create this massive financial ripple effect. So here's the crucial point, and it's less about the technology and more about the culture. This quote from the book just gets right to the heart of that flawed mindset. So many developers tend to ask, okay, but can an attacker really use this bug to do something bad? The authors argue that is completely the wrong question to be asking. The fact that the bug even exists is the problem. The mantra should be simple: just fix it. And that line of thinking leads us straight to the book's core solution. And it really requires a radical shift in philosophy. You have to stop chasing bugs after they're found and start building systems that are secure from the ground up. It's all about moving from a reactive, whack-a-mole posture to a proactive one. This whole philosophy is captured in what the authors call SD3. So secure by design means you're already thinking like an attacker and planning for attacks from the very first blueprint. Secure by default means your product ships with the safest possible settings turned on right out of the box, not just the most convenient ones. And finally, secure in deployment means that even after your product is out there in the wild, you have a solid plan for keeping it secure. It's a full lifecycle approach to security. Okay, so that's the big picture philosophy. But how do you actually apply it day to day? Well, this is where the philosophy turns into a practical toolkit for developers. The book outlines a whole series of timeless principles that become the actual building blocks of secure code. The book lays out several of these key principles, and you can see a few of the real heavy hitters right here. Each one of these is like a mental model for making better security decisions, forcing you to think like a defender. Let's just zoom in on a couple of these to see what they look like in action. First up, defense in depth. This is such a powerful concept. The idea is that your security shouldn't be a single brittle wall that can be knocked down. No, it should be layered, just like a medieval castle. An attacker might get across the moat, but they still have to deal with the giant outer wall. And if they somehow breach that, they still face the inner wall and then the guards inside. The whole point is that no single point of failure should ever lead to a total compromise. Next, let's talk about the principle of least privilege. Now, this one sounds so simple, it's almost just common sense, but you would be absolutely shocked at how often it's violated. A program, or a user for that matter, should only have the absolute bare minimum set of permissions it needs to do its job, and nothing more. I mean, think about it. Your simple Notepad app has absolutely no reason to have administrator rights that would let it delete critical system files, right? By limiting permissions, you limit the potential damage if that program ever gets compromised. But as we start to wrap this up, it's really crucial to understand that these principles, they're more than just a checklist you tick off before you ship a product. They represent a fundamental shift in how an entire team has to think and operate. And this, right here, this is the ultimate takeaway from the entire book. Security isn't a feature. It's not like a new button or a different color scheme that you can just bolt on at the end of the project. You can't just add security in the last week of development. It has to be baked in from the very start. It's a shared responsibility for everyone, absolutely everyone. Designers, developers, testers, you name it. It's a culture of vigilance. So, I'll leave you with this question to think about. All the apps on your phone, the websites you visit, the software you rely on for work, was their security just an afterthought, a happy accident, or was it deliberately, painstakingly built in from the very beginning by design?